Welcome back to Class Time, your daily classroom for CSEC and CAPE subjects. Today we'll be discussing CSEC mathematics, specifically simplifying algebraic expressions.
I'm Camille Johnson-Borrell.
And I am Tamika Lodge-Fenton.
All right, let's get straight into it. Our objectives of the session for today are 1. Simplify algebraic fractions, and 2. Use the laws of indices to manipulate expressions with integral indices. Let us take a look at some important terms for today's session.
Term. This is any collection of letters or numbers that are not separated by a plus or a minus sign.
Expression. This is a group of terms. The terms are connected by plus or minus, or addition and subtraction.
Like terms. These are terms that contain the same combination of letters where the powers, which is also known as the exponent, of the letters are the same, but the numbers can be different.
And algebraic fractions are simply fractions with algebraic expressions in the numerator and or denominator.
Then you have index. The index of a number says how many times to use a number in a multiplication. It is placed to the right upper corner of the base as a superscript. Now let's look at that. So as you can see here, 8 is the base, 2 is the exponent, index or power. So as you can see, those three words are interchangeable: exponent, index or power.
And indices is the plural of index. It provides a way of writing numbers in a more convenient form. So let's take a look at a few examples. Terms. We have 5x, 3x, 3y, and z. These are all separate terms.
Then you have what we call like terms. 5x, 4x, x. Camille, what are those like terms?
Well, I think they're like terms because they're of the same family. They're of the x family.
Okay, so when you look at your terms over there, the first one that you listed, 5x, 3y, and z, they're not the same family?
No, they're not of the same family. If we realize we're 5x, 3y, and z, and this is what leads us into unlike terms. So we would have just listed some terms earlier, 5x, 3y, and z, and now we have some additional unlike terms, 15xy and 4z.
Right, so when we talk about the family, we're talking about the variables. As you can see with the unlike terms, the variables are not the same. 5x, so it has x as a variable, 15xy has xy as a variable, and 3y has y as a variable, and then you have 4z. Let us look at algebraic fraction.
Algebraic fraction, here's an example.
Oh, expressions. We missed expressions.
Oh, yes, we missed expressions. So we have 5x plus 15xy. That's an expression to itself. We also have 3y minus 4z. That's another expression. So 5x plus 15xy. If we look carefully, we will see that 5x is one term, 15xy is another term, and we do have our plus sign there, so it's an expression.
Awesome. So we're now at algebraic fractions. Let's look at that. So we have 3x 12. That is an algebraic fraction. Then we have an algebraic expression with indices. 2x raised to the second power multiplied by 3x raised to the second power.
All right, so based on our terms that we looked at today, I wonder if we have enough information to get into the lesson.
Well, I think we gave a lot of information. Let's begin the lesson.
Let's take a quick look at what we have. So we're going straight into simplifying algebraic fractions. So here goes. We have a squared plus 3a all divided by a, and we're asked to simplify this algebraic fraction. Now let's see if Tamika can simplify this based on her knowledge that she would have gained before. Let's go. Let's take a look at what Tamika is doing.
So just as any fraction, we're talking about the numerator and denominator. So when we're going to simplify, we need to figure out if there's anything common with the numerator versus the denominator. Anything common with them. So let us look at our numerator first. there are two terms here. I have a squared subtract 3a. Is there anything common with those two terms? Yes. So I'm going to factor out what's common. So I have a is common to both a squared and it's also common to 3a. So if I were to factor out a from a squared, I'd have a left. If I factored out a from 3a, from negative 3a, I would have negative 3 left. And of course, we have one term there, one value in the denominator. So that's pretty much it. I've factored out a. So now I have a, open bracket, a subtract 3, close bracket, all divided by a. Can I still simplify, Camille?
No,
Of course we can.
So. You're sure?
Yes, man. We have something common in the numerator and in the
yes.
denominator.
Yes.
So I can factor out a again. If I factor out a here, what do I have left? I don't even need that bracket anymore. So all I have left is a subtract 3. So let's see what you have.
Let's see if Tamika is correct. So she did start by saying we need to find the highest common factor. So that's 1 point. Right? So she has it right. She has it right. But let's get way down to let's see our solution. So she did simplify it. And voila, she is indeed correct. Kudos, Tamika. Kudos.
All right, so just for those who probably wasn't following with me, let's just repeat what we did. So we had a squared subtract 3a all over a, or divided by a. Then we factored what is common in the numerator, which is a. We ended up with a, open bracket, a subtract 3, close bracket, all over a, or all divided by a.
Yes.
And then we would have factored out a in the denominator from a in the numerator. So now we end up with a subtract 3.
All right, that's good job. Let's try another one. So we have 3a all divided by a minus ab squared. So since as Tamika was such a bright spark on the first one, we're going to see if she's able to do this one.
All right,
So
we
it's
have
3a all divided by a minus ab squared.
All right.
So let's see if we can help Tamika and walk through. So when we look at our numerator, we're seeing 3a, which is a term to itself. When we look at our denominator, we have a minus ab squared. So in looking at our denominator, we realize that our highest common factor would have been a in our denominator. So we would now have 3a all divided by a, open bracket, 1 minus b squared. Let's see if we can simplify this a little bit further. So let's look at our numerator and our denominator, still linking it to fractions because remember we're doing algebraic fractions. Now if we look at our numerator and denominator, we realize that we do have a common factor, which is a. So we can simplify this algebraic fraction. So go ahead, Tamika.
So we're going to factor out a from both the numerator and denominator.
Yes, that's
so
right.
A into a 1 time, a into 3a goes 3 times. So now we end up with 3 all divided by 1 subtract b squared.
Good. Good job. Good job. Right, that's right. Right, good job, Tamika. But let's take a look at one more just to ensure that we're following. So we have 3x plus 6 all divided by 3x squared. Now, based on what we would have been doing earlier, we know that we would have to look at our numerator and denominator, recognize if there's an expression, and then we do our simplification by finding the highest common factor. So if we look at our numerator, we know that our highest common factor in our numerator would be 3. You think I'm correct, Tamika?
Yes, you are definitely
it's
correct.
3. So we know we would have 3 open bracket x plus 2. That would be our numerator. And our denominator would still be 3x squared. Now, when we take a look here, we have 3 open bracket x plus 2 all divided by 3x squared. Let's look at our numerator and denominator. Can we find a common factor between both? Yes, we can. 3. So we're now simplifying our numerator and denominator using 3, using the factor 3. So in simplifying now, we have x plus 2 all divided by x squared. Question, Tamika. Do you think we can simplify this answer any further?
Well, let's look at it. So we have x plus 2 as our numerator, and we have x squared as our denominator. No, no, we can't. That's it. And that is because the x plus 2, two separate terms, but there's nothing common with the two terms that we have in our numerator, right? So we can't factorize anything out there, and we definitely can't factorize across that plus sign from the denominator's perspective. So that is our simplest form, x plus 2, all divided by x squared. That cannot be simplified any further.
Good observation, good observation. So just to recap, what we would have looked at when we're simplifying algebraic fractions, 1, we factorize the numerator and or the denominator where possible, and 2, we simplify using the highest common factor. Let's take this a little bit further now to multiplying algebraic fractions. So we have our first algebraic fraction, 4a fifths, multiplied by 15b sixteenths. Let's see if Tamika can use what she learned earlier.
All right, so the first thing I am going to always try to do is to simplify my algebraic fractions. How can I simplify it? Look for common factors. All right, so I can see that with the 4 and 16, common 4a and 16 have 4 as their highest common factor. So I'm going to factorize 4 out of 16. 4 into 16 goes 4. 4 into 4a leaves a. And then I have 5b and 5. 5 is the highest factor. 5 into 5. 5 divided into 5, 1. 5 into 15b gives me 3b. All right, so let me rewrite what I have now. So I have a multiplied by 3b, all divided by 4 multiplied by 1 gives me 4. That looks right to me. What do you think?
You sure that's in its simplest form?
Well, let's see. This a, let me just make sure it looks like an a and not a 9. That a, so a is the first term multiplied by 3b. Oh, you know what? I can multiply that out. So 3ab all divided by 4. That's it.
Yes, that's it. Good job. Good. And that's exactly what I got. That is exactly what I have. There goes. So let's take it a little bit further now. And here we just want to recap when we're multiplying algebraic fractions. 1, we simplify using the highest common factor. And 2, we multiply the numerators and then we multiply the denominators. So we would have looked at simplifying algebraic expressions, simplifying algebraic fractions. We would have looked at multiplying algebraic fractions. Let's see if we can go a little bit further now to dividing algebraic fractions. So let's go. And again, because Tamika loves the board, she loves to write.
Oh, yes.
Tamika is going to do this one for us. So we have 11 divided by 9x squared y divided by 77y divided by 15x.
All right. What do we know about fractions when we're dividing by fractions? What do we tend to do?
I remember about fractions when we are dividing that we multiply by the reciprocal of the divisor.
Excellent.
So since I know that, I do believe we can incorporate that knowledge with algebraic fractions, bearing in mind that algebra and fractions are seen as two challenging topips. But they're not, you know, they're not. By the end of the lesson, they should see that they're not at all.
Excellent. So the reciprocal of 77y all divided by 15x would be 15x all divided by 77y. All right, so once again, we are looking for common factors, the highest common factor. So let us look what we have here. We have 11, 77, 9, 15 as numbers there. What's variables? We have x and y. Let's see what happens. So 11 and 77 have something in common. 11 is a factor of 77. So 11 into itself goes one time. 11 into 77y goes 7y. And then you have 15x and 9x squared y. What's a factor there? 3. But they
Not
also
only
have
3,
something else in common. They have an x.
Yeah, man, they have
so
x in common.
3x. So if I were to factor out 3x out of this, I would get 3. 1x is still there, and the y. 3x into this, 5. All right, so let us write what I have. Let us calculate. So 5 multiplied by 1 gives me 5. 3 multiplied by 3xy multiplied by 7y would give me, that's 21xy squared.
All right, that's good, that's good. So just recapping, doing a little summary then of what Tamika would have just looked at. When dividing algebraic fractions, the first thing that we need to do is multiply by the reciprocal of the divisor, which is the first thing that she did. Then when she did that, she looked to see if she could find any highest common factor then within the numerators and denominators. She would have found her highest common factor, and then she went ahead after simplifying to multiply the denominators and multiplying the numerator, which is how she has 5 all divided by 21 x squared x y. Yes, so it's 5 all divided by 21 xy squared.
Dividing algebraic fractions. To divide algebraic fractions, 1, we must multiply by the reciprocal of the divisor. 2, simplify using the highest common factor. 3, multiply the numerators, multiply the denominators.
So if you didn't catch it first when I shared it with you, Tamika would have just shared it a second time. So you should know how to divide algebraic fractions. Let's step it up a little bit now. Let's step it up. Let's see what's happening. So now we're looking at adding and subtracting fractions. We have 2/3 plus a quarter. Anything you remember about adding fractions or even subtracting fractions, Tamika, from way back then? I know that.
Well, I know that if they're from different wholes, I can't operate with them. I can't add or subtract if they are represented from different wholes. And you have thirds and quarters there. That's a problem right there.
That's simple saying to me then that, hey, they're from different families, so we need to get them a part of the same family, which getting them a part of the same family is getting them a part of the same whole. Nice. So we already established that. So since we're getting them a part of the same family, we know that we need to find the equivalent fractions of them then. Nice. Good. So after we would have found the equivalent fractions of these fractions, what do you think we're going to do then? They're of the same family.
Before you get that though, how are we going to find the same family? What do I need to look at?
You know, I remember something. We can look at our denominators here to find the same family.
Exactly. So we need to figure out what multiples.
Yeah, man, multiples is ringing a bell
The lowest common multiple.
Yes, it's ringing
All
a bell.
right.
It's ringing a bell.
So we have 3. So now if you are just doing this for the first time, you may want to you can list them, or you may really just know them. So if you look at the multiples of 3, what we start with, so it's 3, then we have 6, 9, 12, 15. We're just going to stop there for now. Then you look at 4, multiples of 4, start with 4, 8, 12, 16. So what is the lowest multiple, common multiple for 4 and 3? Looks like 12 to me. What you say, Kame?
Yeah, man, I think it's 12. It's definitely 12. Can't be any. We have other multiples, you know. There are many more multiples that are common between 3 and 4. However, 12 is the lowest common multiple between both. And one thing that we know too, when we're doing equivalent fractions, it is basically another way of representing that fraction.
Most definitely. So let's look at the fractions. So we have 2/3, and we want to see what would have happened to 3 to get it to 12. So we divide 3 into 12, we would have, and you get 4. So that means you would have multiplied 3 by 4 to get it to 12. Remember, when you're working with fractions, whatever is done to the numerator must be done to the denominator or the other way. So 3 divided into 12 gives me 4. 4 multiplied by 2 gives me 8.
Yes.
And 4 divided into 12 gives me 3. 3 times 1 gives me 3. So what we're saying, 8/12 is equivalent to 2/3, and 3/12 is equivalent to a quarter. So now they're of the same family. We can definitely
add.
add.
Seeing that we're adding here, we can just add none. We're not going to be adding. Seeing that they're of the same
Exactly.
family, remember now, same family, same whole. We don't need to do anything to our denominator. We just need to go ahead and add our numerator here. So we now have 11/12, which is exactly how I looked at it. Here goes. 11/12. So we are indeed correct. So since we remember about fractions, let's look at adding and subtracting algebraic fractions. One, as we would have shared earlier, just as how we would have done with normal fractions, we find the equivalent fractions within the same whole. Two, we add or subtract the numerators based on what operation we're given. And three, we simplify if possible. Now, the one that Tamika did before, 11/12, could not have been simplified any further because it's already in its simplest form.
Meaning there's no factors
None common
with the
between both.
numerator and the denominator.
Yes, that's right. Let's look at this example. 4x, 4 divided by x minus 5 divided by 2x. So let's take a look at this one now. So based on what Tamika would have just said, we are now going to be finding the equivalent fraction. So if we look at our denominators, we have x and we have 2x. So in finding our equivalent fractions here, or equivalent fractions here, we do know it has to do with our denominators, right, Tamika?
Yes.
It does, right. And in looking at our denominators too, getting them to be as part of the same whole, sometimes we have x and we have 2x. If we multiply both of them, it's going to be of the same family. So instead of listing all the multiples of x and instead of listing all the multiples of 2x, we could go ahead and multiply both denominators to arrive at a family name. But guess what? Not all the time. That family name will be the lowest common multiple. And that is why we look at the lowest common multiple
Right.
when we're doing this.
But just to remind them, if they do multiply both denominators, it simply means as you work your problem down, when you reach to your correct answer, you're just going to have to simplify that.
Yes.
So if that's the last resort, go ahead, do it that way. But for here, I've gone and I've listed factors, multiples of x, which should be x, 2x, 3x, and we could continue. Multiples of 2x, 2x, 4x, and right away we could see that 2x is common to both denominators, so we can now rewrite them from the same family, which is 2x, and then we can operate. So of course 2x remains. Now x divided into 2x gives me 2.
2 times.
2 times
4
4.
times 2 is 8.
There you go.
And now we need to simplify. So 8 minus 5. Remember, we have not, both of them are equivalent fractions. They belong to the same whole. So we just need to subtract the numerators, which is how we have 3 divided by 2x. Good job. Good job, Tamika. So since we would have looked at algebraic fractions, we're going to step it up. So we're looking now at indices, and we're looking what is an index number. So you should already know, 8 times 8 times 8 times 8 times 8 times 8 gives you what? So let's count 1, 2, 3, 4, 5, 6. I counted 6 8. So that means it's 8 raised to the 6th power. So we do say 8 raised to the 6th power. And here our 8 is the base, while 6 is an index and it tells the power of the base. So since we have an idea then what indices are, let's take a look. So here we have an algebraic fraction. V raised to the 3rd power, W raised to the 5th power, Y, all divided by V squared, W raised to the 5th power, y raised to the 5th power. Now, we looked at algebraic fractions earlier. We did simplifying algebraic fractions. We looked at adding, subtracting, multiplying, dividing. But guess what? This one looked very sticky.
It has a lot of things in it.
Yeah, man, I don't remember us doing any like this before, you know, so this looks sticky. But I remember something in high school, that when we're looking at these type of algebraic fractions now, I love to take the long route.
Yes, we do.
So guess what? I would go ahead and expand. I'm going to write what each means. So my v cubed means v multiplied by v multiplied by v.
Excellent.
My w raised to the 5th power would be w multiplied by w multiplied by w multiplied by w multiplied by w, and it goes on. Yes, you know what I'm
So we're
talking
seeing a
about.
pattern here.
Yes.
The index for each variable tells you how many times you need to multiply that variable.
Yes, that's the pattern. Good observation. I like it. I like it. Good observation, Tamika. So guess what?
Yeah.
Let's expand.
So we have v raised to the 3rd power. As you can see, v is being multiplied 3 times. W raised to the 5th power 5 times. Y, it has
1
nothing.
time.
It has nothing.
Yes.
What does that nothing mean?
No, but even though it has no power, there's still one y there.
Okay, so it's 1
So
y.
it's-
So we put back the 1 y.
Well, not one y, but y raised to the 1st power.
Okay.
Yes.
Awesome. Then we have v raised to the 2nd power, which we have v multiplied by itself twice, and w to the 5th power 5 times, y to the 5th power, y multiplied by y 5 times.
So after we would have expanded our algebraic fraction here, then we're going to do something similar to what you would have been sharing with us earlier. We simplify.
Right, so we look for common factors. So v is common to both numerator and denominator. So you factorize where possible.
Nice. So when we factorize where possible, this is my answer. V all divided by y multiplied by y multiplied by y multiplied by y. Lots.
And we can simplify that.
To be v divided by y raised to the 4th power. But I'm wondering something, Tamika. I'm wondering something.
Yes, let us look at it over here. So you have v, okay, so you had 3v in your numerator and you had 2v in your denominator, but you
Yes.
just have 1 now. Let us look at that. So we have, I'm just going to separate them for a minute.
Hold on, man. But even separating them for a minute, while you're writing,
Right.
is there anything that we can look at, we can observe with our powers then to arrive at this answer? Do you think so?
I think so, because
Maybe
if
a
you had
short way?
3 here and you had 2 here and you ended up with just 1 there, it would look as if you did v3 subtract 2. Gives me that.
Right. Nice. What about the W? What about the W?
W, no, the
we don't
W
have any
have-
W in our answer, you know, so what about the W?
All right, so I'm separating it again. I'm just doing it part. So I have 5 here, w to the 5th power, divided by w to the 5th power. So let's see, if I did that, it means w 5th subtract 5.
Yes.
That looks right?
Yes, subtracting
right.
the powers.
And then I would end up with, wow, what is that? So I have, you know what? I just don't have any w left.
We don't have any W.
So I'm sure we're going to talk about that.
Yeah, man, we're
that
going
0 power. So we just don't have no W. All right. So and as you can see, if you're factorizing W to the 5th power, it pretty much factorizes out each other, leaving 1. All right. Then we have the Y.
Y, yes.
So we have Y to what again? We started off with Y.
Y to the, even though we don't see 1 there, remember we realize that it's y to the 1 power.
So it's Y to the 1 power subtract 5, which would give me, I'm just going to write it out. I'm not even going to do that. So it's going to give me Y negative 4. These are all things that we're going to talk about.
Yes, we're going to talk
Right?
about.
So, and as you can see, I can see my 4 Y's to the base, to the denominator there.
Yes.
All right.
It's there. So let's go ahead. Let's move ahead. So we're looking now at another example based on what we would have done earlier, where we would have, Tamika would have shared with us that she would have subtracted the powers to, which is a short way to what I love to do. We have 3 raised to the 5th power divided by 3 raised to the 2nd power. Now, something that is very important to notice when we're doing indices is that both terms have the same base. So if we want to know, you want to know what I mean by same base? Look at this. So you have 3 here, and you have another 3 there. That's what I'm talking about when I say same base. So it's 3 raised to the 5th power divided by 3 raised to the 2nd power, or we can say 3 squared. We can just go ahead and subtract. So it would be 5 minus 2, which would be 3 raised to the 3rd power. And this is my long way that I love to do it. So this is my long way. I expanded my numerator, expanded my denominator, arrived at 3 cubed. So now we are looking at, when generalizing, dividing with indices, what happens? We would have shared this earlier. A raised, any base raised to the power, any power, divided by the same base raised to another power, it could be the same power, is equivalent to A. We're subtracting both powers, m minus n. Let's see if we can take a look at multiplying with indices.
So we have example 1 here. So we have 2 raised to the 3rd power multiplied by 2 raised to the 4th power. As you can see, they are of the same base. So let's see, if we were to expand what this would look like. So we have
2 raised to the 2 cubed. 1, 2, 3
multiplied by 2 to the 4th
power. 1, 2, 3, 4.
Now, just from looking here, you can pretty much count the number of 2's you have to see how many times you're multiplying 2. And you would get 2 raised to the 7th power. So,
let's look at our powers. We have 2 cubed multiplied by 2 raised to the 4th power. Now, if when we were dividing, we had terms of the same base and we subtracted the powers. If we're multiplying same base, I think we're going to add,
but you can look, 3 and 4, 7.
If
you look at it. So, it's as you can see, proven here when you expand. If you were to just add the bases as you multiply, if you were to add the exponent index, as you multiply the same base, you would pretty much get the correct answer.
See, and tell me something bright.
You are brilliant, Camille. Brilliant, brilliant.
Just a wonder, just a wonder. Since as I bright, but I know you brighter, I want you to explain to me how we're going to do the next one.
Oh.
So we're stepping it up.
So we're still multiplying with indices. However, look at those index values. We have a half and 3 halves.
Yes.
Can you imagine? All right. So when you are multiplying with indices that are fractional, let us look what the fraction means. So we have 2 raised to the half. Now, the denominator and numerator tells you something. So the denominator tells you what root you are going to operate on with. So the half tells us it's a square root. Now, by now you should know that this sign already says square, so no need to put a 2 in the square root. And the power for the base would be 1. You should also realize that we don't write 1. However, you can, but it's not necessary. So we're finding the square root of 2, correct?
Yes.
And then now we have, over here we have 2 raised to 3 halves. So remember the denominator tells you what? That it's a square root.
Square root
and
of 2, and
the numerator tells you the power. So 2 to the 3rd power, 2 cubed is, so let's write out the entire problem now, or you want to just do it on the board for them?
I can,
Yeah, you just do it.
I am going to do it on the board for them right here because honestly, what I'm going to use is what I just did. So since as we're multiplying indices, same base, all I'm going to do is I'm going to add my powers. So you see that long way that you take it? No, man, I learned something new today and I'm using it. So I'm just going to go ahead, add my powers. So when I add half plus 3 halves, we would have just looked at fractions, same whole. 1 plus 3, 4. So it would be 4 halves. 4 halves is the same as 2.
It is.
That's my answer, see? Me finish before you. I brighter now.
Yes, you are.
All right, good job. So let's go on now. So just to recap what we would have just looked at, when we're multiplying indices, the terms, same base as we're seeing A being our base here, powers, we just go ahead and add. Let's step it up a little bit further now. So what if we had powers? So if we look here, we have 3 raised to the 4th power, all raised to the 2nd power. Now, linking it back to what we would have looked at earlier, and what we would have learned too, anything raised to a power, you know you're going to multiply it that number of times. So here I would go ahead and say 3 raised to the 4th power multiplied by 3 raised to the 4th power. And again, I would have learned that same base, so I would have gone ahead to add. So in going ahead to add my powers, I have 8.
Right.
But I also recognize too that I could have gone ahead and multiplied by my powers. So it would be 4 times 2 to give me 8. So see if you can tell me now, based on what I would have just shared, if you think we can come up with a pattern and how, if we see any other indices looking like this, what we're to do.
All right, so as our title said, powers of powers. So we're multiplying a base, where a base is raised to a power, and then it is raised to a 2nd power. All right, so 1, you can expand, as we've been doing. So 3 raised to the 4th power squared, so you're multiplying that value by itself, as you can see there. And then you pretty much, if you were to open it up, you would get the 8 3s. But from observation, you can pick up patterns.
Yes.
So 3 raised to the 4th power multiplied by 3 to the 4th power can be simplified, written by just adding the indices, which is 4 plus 4 is 8, or, as you can see from observation, 4 multiplied by 2, which are the indices, also gives you 8. So you have 2 options.
Nice,
All right.
we do. So our second example now, we're just going to run through it because we're bright like that. Same power, we know that, all right, it means A raised to the 5th power times A raised to the 5th power. We can go ahead and add our powers here to have given us, what do you think our answer is?
5 plus 5 plus 5 gives us 15.
15?
Excellent.
Yes, you're correct. So it's 8 A raised to the 15th power. And again, we can just multiply our powers. So it's 5 times 3 to also give us 15. All right. So recapping now, when a term is raised to a power and the result raised to another power, the powers are multiplied. We would have just looked at that. A special case, we are asked now to simplify 2 raised to the 4th power divided by 2 raised to the 4th power. Now in simplifying 2 raised to the 4th power divided by 2 raised to the 4th power, I'm going to go ahead and do it the long way. So in doing it the long way now, we have this. 2 times 2 times 2 times 2, all divided by 2 times 2 times 2 times 2. And in simplifying, I realized that we are left with no 2's.
So you have factored out all the values in both the numerator and the denominator.
Yes. So when I factorized, I have 1.
Excellent.
Nice. But guess what? What if we want to do it another way? So what if we want to do it the shortcut?
Right, because we learned now that 2 raised to the 4th power, when divided by the same base to another power, we can subtract the indices. So we'd end up with 2 raised to 4, subtract 4, which would give us?
2 raised to the 0 power.
Right, remember we had touched it in the y thing that we were doing?
But because we had done it the long way a while ago and we realized that it's 1, we can now say that any base raised to the 0 power is 1.
Right.
Nice, and Tamika got it right.
And pretty much what you're saying is that you're dividing one number or one value by itself gives you 1. Okay.
Let's take a look at this one now. 5 cubed divided by 5 raised to the 7th power. In looking at 5 cubed divided by 5 raised to the 7th power, we realize here that, hey, we can go ahead, subtract, so we would have 5 raised to the negative 4th power. And if we want to do it the long way,
we could definitely expand and factorize, and then we'd see that it works out to be the same that we would have just used.
So 5 raised to the negative 4th is the same as 1 divided by 5
And just to note,
to
the negative exponent means that it appears in the denominator of a fraction. If you were to write it in a fractional representation, it would be in the denominator.
And we are now at our summary. We looked at the laws when adding indices, same base. We add the powers. When dividing indices, same base. We subtract.
Powers.
We multiply powers. And we a to the raised to the 0 power, any base raised to the 0 power is 1. Any power, any number or base raised to the negative power is 1 divided by a raised to that power. And our rational numbers here that we would have looked at.
Right. So just remember, that's all the time we have for today's lesson.